Good day everyone, especially to our grade 9 learners. For today, we are going to discuss one of the topics for the second quarter, and that is direct variations. At the end of the lesson, you are expected to translate variation statements into mathematical equations and solve problems involving direct variation. Direct variation is a type of relationship between two variables which are directly proportional to each other. This means that if one variable increases, the other also increases. If one decreases, the other one decreases also. So let us have examples of real-life situations that denotes direct variation. For the first example, if the number of articles purchased increases, the total cost also increases. Ibig sabihin, mas marami kang binili, mas malaki ang babayaran mo. Mas kaunti ang binili, mas maliit ang babayaran. Second example, the more money deposited in a bank, the more interest is earned. Mas malaki ang pera na dineposito mo sa bangko, mas malaki ang interest na kikitain mo. Or, mas maliit ang pera na dineposito mo sa bangko, mas maliit din ang interest na makukuha mo. Third example, the number of hours you work and the number or the amount of your paycheck. Mas marami kang oras na ginugol sa trabaho, mas malaki ang susweldohin mo. Pero kung kaunti naman ang oras na ginugol mo sa trabaho, mas maliit din ang iyong susweldohin. The next one, the speed of a car and the distance traveled in a certain amount of time. Mas mabilis ang sasakyan, mas malaki ang distansyang matatravel niya. Pero kung mas mabagal naman ang sasakyan, mas maliit ang distansya na kaya niyang i-travel. Tandaan, sa direct variation, habang tumataas ang isa naman ay tataas din. At kapag ang isa naman ay nag-decrease, the other one also decreases. If a situation is described by an equation in the form y equals kx, where k is a non-zero constant, we say that y varies directly as x, or y is directly proportional to x. The number k is called the constant of variation or the constant of proportionality. Kung mapapansin ninyo, madalas nating makikita yung mga words na varies directly at directly proportional if we are denoting or pertaining to direct variation. Let us translate the following into mathematical equations. Let's have the first example. A varies directly as B. The keywords here are varies directly. So in equation, it would be A equals KB. Second example, X is directly proportional to Y. The keywords here are directly proportional. Therefore, in equation, it would be X equals KY. In the third example, the cost Y of rice varies directly with the number X of kilos purchased. The keywords here are varies directly. So what do you think will be our equation? Yes, the answer is y equals kx. Now let us discuss how to solve problems involving direct variations. I will be showing you 4 steps. These 4 steps are also the same steps that you can use in solving other types of variations. Step 1. Write the correct equation. Remember that direct variation problems are solved using the equation y equals kx. Step 2. Use the information given in the problem to find the value of k or the constant of variation. Step 3. Rewrite the equation from step 1, substituting in the value of k found in step 2. Step 4. Use the equation found in step 3 and the remaining information in the given problem to answer the question asked. Let us have example number 1. If y varies directly as x and y equals 10 when x equals 2, find x when y is 25. Again, our step 1, write the correct equation. Remember that direct variation problems are solved using y equals kx. In our example, y varies directly as x. Therefore, our equation is y equals kx. Please take note that variable use can be different in some problems. Step 2. Use the information given in the problem to find the value of k. In this case, we need to find k when y equals 10 and x equals 2. Remember, y equals 10 when x equals 2. Let us substitute these values of y and x into the equation y equals kx. Remember, y equals 10 and x equals 2. When you simplify, k times 2 is 2k. We'll have 10 equals 2k. Then, divide both sides by 2. You will have k equals 10 over 2. When you simplify, k now is equal to 5. Therefore, our constant of variation is equal to 5. In step 3, we have to rewrite the equation from step 1, substituting in the value of k found in step 2. Remember, in step 2, we find the constant of variation, which is equal to 5. Now, from our equation in step 1, y equals kx. We now replace k by 5. We now have our equation y equals 5x. For step 4, you use the equation found in step 3 and the remaining information given in the problem to answer the question asked. Remember, y equals 5x is our equation in step 3. Now, we need to find x when y is equal to 25. So we just need to substitute the value of y, which is 25, to our equation in step 3. So 25 equals 5x. Since we are solving for x, we need to divide both sides by 5. So 5x divided by 5 is x, and 25 divided by 5 is 5. Therefore, x is 5 when y is 25. Let us have example number 2. The distance t traveled by a car is directly proportional to the amount of liters L of gasoline it consumes. Suppose a car uses 5 liters of gasoline to drive 40 kilometers. How much gasoline will the car require in order to drive 128 kilometers? Let us answer this using the 4 steps in solving direct variation problem. Step 1. Write the correct equation. Remember, direct variation problems are solved using the equation y equals kx. This is a variation problem since we have here keywords such as directly proportional. But notice that we are going to use a different variable in this problem. So since d is directly proportional to the amount of liters L of gasoline, we are going to have d equals KL as our variation equation. Let us have step 2. Use the information given in the problem to find the value of K. Remember that the car uses 5 liters of gasoline to drive 40 kilometers. So D equals 40 and L equals 5. So we just need to substitute the values of D and L into the equation in step 1. So D equals KL. So D will be replaced by 40 and L by 5. Simplify. 5 times K is 5K. 40 equals 5K. Then we need to divide both by 5. 5K divided by 5 is K, and 40 divided by 5 is 8. Therefore, the constant of variation is equal to 8. Now let us have step 3. Rewrite the equation from step 1, substituting in the value of k found in step 2. Remember, our constant of variation in step 2 is 8. In step 1, we have the equation d equals kl. So since we already have the value of k, which is 8, our new equation would be d equals 8l. Now let us have the last step, step 4. Use the equation found in step 3 and the remaining information given in the problem to answer the question as. In step 3, we have the equation D equals 8L. We only need to find the number or how much gasoline will the car require in order to drive 128 kilometers. In this case, we need to find L when D equals 128. So let us substitute. If D is 128, you will have 128 equals 8L. Since we are solving for L, we divide both by 8. 8L divided by 8 is L, and 128 divided by 8 is 16. Therefore, the car needs 16 liters of gasoline when driving 128 kilometers. I hope you learned something today. Thank you for watching and happy learning.